finding the limit of some of these functions here. If, have a look first to see if there's a problem with something being undefined. For this one, there's not. This denominator, you're subbing in 1. You can just directly sub it in as is. You could say that this is equal to the limit as x approaches 1 of that top function if you want, divided by the limit as x approaches 1 of that bottom function. Or, since this expression is defined there, you can just substitute that value in. Essentially what you're going to have is 1 to the 4th plus 1 squared minus 1 over 1 squared plus that, 1/6. Again, you can graph this function. You can y1 equals that, find the value when x is 1. That's what that limit is. Here's where our problems might start, because we want to know what's the limit as you approach 1. Okay, this is the real reason we're talking about limits. If it was just for things like this, it's not worth talking about. If the function is defined to be the same point as its limit is all the time, at a given point, then it's not much need for a concept of limit. For this one, this is equal to the limit of this function but simplified. So if we can factor this, x plus 2, x minus 1, x minus 1, it does factor to that, and you can simplify, get rid of that stuff. Now it's probably better if you actually rewrite it rather than crossing things out, because pretty soon then you have a big mess of stuff crossed out. Limit as x approaches 1 of that, then you can substitute it in. When you're substituting it in, that's when you're actually evaluating this limit. So from here to here, I've simplified the limit. I've simplified that expression I'm working with. Now, since I'm actually evaluating it, I'm not going to write limit anymore. I'm just going to write it's 1 plus 2. I've subbed it in. I've subbed in this 1 right here, right? That 1 has gone in there. Okay, subbing it in because there's no problems with it anymore. Alright, so the limit there is 3. If you graph this function, you'd notice there'd be a hole in the graph at 1. But it would look like that value should be 3. Okay, I'll leave that up to you to do. You can check. Now you're going to have some limits that we're going to look at where there are problems here. All right. Can we simplify this at all the way we did with the ones above there? The limit as x approaches 1 of that. You can't, right? There's no way to simplify that. If you look at the graph, though, you can think about how the function behaves as you get close to that. So put in 1 over x. Sorry, it's 1 over x minus 1. Do this again. So that function is asymptotic here at that value x equals 1. If you want to know how the function is behaving there, think about as we approach 1 from the right or from the left here. Okay, you can see the cursor there. You're not going to see it, but you can follow the values here. We're approaching 1 from the right. The limit as x approaches 1, or sorry, from the left. So I'm coming from below 1 here. Those values are getting more and more negative. And then at 1 itself, it's undefined. On the other side, as you approach 1 from this side, the values are getting bigger and bigger, right? As I get closer to 1 from that side, these are getting bigger and bigger, and it's undefined there. The problem is here is from one side and from the other side, they're not behaving the same way. This function actually has different limits as you approach from either side. If the two sides don't agree, if the limit as you approach from the left is different than the limit as you approach from the right, it doesn't have a limit at that point. You can say it has one-sided limits, but it doesn't have a two-sided limit that you just say is the limit as you approach 1. So for this, we're going to say does not exist. Kind of like undefined. I don't know why they say does not exist for this. For limits, they talk about the limit does not exist instead of saying the limit is undefined. There is no limit for that. There's one-sided limits. One way the graph looks like it's headed for positive infinity, and the other way the graph looks like it's headed for negative infinity. Since those are different, they don't agree, and there's no two-sided limit.